All right, welcome back. Today we're going to talk about MCP, or the Model Context Protocol as it is known. Now, if you've been paying attention to this, it's been kind of, I would say, in the news or on YouTube quite a bit. Recently, when it came out, everyone was talking about how great and revolutionary MCP was. And I'll be honest, I couldn't get my head around it. I watched a bunch of videos, I put demos together. I was like, okay, it seems great, but I don't really get it. So, what I'm going to do today is walk through at least how I came to an understanding of what MCP is. And we're going to start with looking at it very conceptually, like where we forget about code, systems, and everything else. But then we'll actually dive in and show you some code and how it works. So, with that, why don't we jump in? And we're going to start with just ChatGPT in front of us. Now, I want you to forget about protocols, invoking services, everything else for a minute, because once I put that aside, I was able to get to a better understanding of what MCP is. Now, in front of us, we have ChatGPT, which is running a model. Now, obviously, this model can reason about all kinds of different topics. Now, imagine for a second that I want to give this model tools that can help it do its job. Now, this is one of the things that you'll hear a lot with MCP is it like standardizes how these models can use tools. But I was like, I don't even understand what that means. What does it mean for a model to use a tool? And they'll show examples of the models using things like Google Drive, ingesting documents, et cetera, and standardizing that. But let's look at this model. And now let's pretend for a second that I am actually going to be the one that executes tools on its behalf. And so what we're going to do is I'm going to tell this model theoretically that it has a bunch of tools. Now, I'm going to give you a concrete example of a tool. I'm going to tell this model that I'm going to give it a tool that can add two numbers together. And once we tell the model about the tool, then what I'm going to do is I'm going to ask the model to solve problems using the tools I tell it about. Right. And so in this, what you'll see in this example is like this is just changing my interaction pattern with the model, and we're essentially solving problems together. And so let me walk you through an example. So what I'm going to do here is I am going to describe to the model the tools that it has available. So let's do this. So let's walk through what I'm about to tell ChatGPT. So what I said is I'm going to tell you about several tools you have to solve problems. I can use these tools on your behalf and tell you the results of using the tool. After I tell you about these tools, I'm going to ask you questions that you should solve using the tool. The first tool adds two numbers together. You give the tool two numbers and it will tell you the result. The second tool returns the digits of pi to the number of digits you specify. So let's see what it says. I did not pre-plan this prompt. Like I've played with this a little bit and done it different ways, but we'll do this live in real time. Okay. So what it said is like, great, I understand. Describe two tools, addition and a pi digits tool. It says, when you're ready, go ahead and give me a question or problem to solve these tools. See how we're now like, think about this in the back of your head of take the little information you have about MCP and you can, if you have any, and you can start to map this in. We're basically telling the model that, hey, I can do some work on your behalf. I have capabilities you don't have. All you have to do is tell me what you need me to do, right? So now you can get the model reasoning about how to solve problems using capabilities it doesn't inherently have. In this case, I'm the person providing those capabilities. What we'll see going forward is you can provide those capabilities through other services. So it can be done programmatically. So let's just ask it something simple. Let's now ask it to add two numbers. So we'll say, okay, let's add 2 and 3. Let's see what it says. Now, this is interesting. To solve this using the addition tool, input 2 and 3, output 5. The result is 5. This is not what I would expect because remember, I told it to ask me to use the tool, so it didn't do that. We're just doing this as an exercise to learn, but let's just kind of work through it and prompt it a little bit to correct its behavior. All right, so basically I'm going to tell it, you didn't do it right. Let's see if it gets better. Okay, so here. To solve your request to add 2 and 3, I will instruct you to use the addition tool. Please run the tool and tell me the result. Okay. Okay, 5. So now it shows correctly the answer is 5. Now let's make this a little more complicated. Let's ask it to add more than two numbers together. And what it should do in reasoning on solving the problem, if I ask it to add 1, 2, and 3, you would think it would invoke this addition tool twice. So let's give that a try. So I said now add 1, 2, and 3. Oh, interesting. Here we go. See, now this, when I started to play with this is the aha moment. So now you have this model reasoning about how to use tools to solve a problem, which you can see here. And so it's like, okay, using the addition tool, which only accepts two numbers, we need to break the problem down. I didn't tell it to break the problem down. So step one, use the tool with first number 1, second number tool 2. Please run the tool and tell me the result. I'll say the answer is 3. Great. Now use the tool again, says 3 and 3, and I'll say the answer is 6. So there you go. So this I thought was really neat, where you start to see, like I said before, how it reasons about using these tools. So we're going to try something. I'm going to trick it now. So I am, behind the scenes, obviously it can do some math, but I'm going to have, my tool. I'm going to say like I can't add. So let's add a few more numbers. So let's add 4, 5, and 6. See if it goes about the same way. Okay. Use the tool with the first number 4 and 5. So let's say that our addition tool says 4 plus 5 is actually 6. See what it says. So you've reported a result of 4 plus 5 is 6. That doesn't match what we'd expect. 4 plus 5 should be 9. Can you please double check? I thought this was fun, but now I'm going to tell it that it must follow the results of the tool. So I said it has to accept the results of the two tools. So it said you reported 4 plus 5 is 6. Now it moves on to step 2. And so the first number is 6, and we have to add the remaining 6 to that. And let's say our tool says 6 plus 6 is -2. So here we go. Therefore, the result is 4 plus 5 plus 6 is -2. So I thought that was fun. And it's just interesting to see that, the model is still, in a sense, it knows when something isn't quite right and pushes you on it. We won't see that when we get into the programmatic side. But okay, let's try. I also told it about a pi tool. So let's give that a try. So I asked it, I'm like, I want to learn about the number pi. Give me a short history of the number pi and then tell me the value to 2 digits. And you can see here again, what it does is it breaks it into 2 parts and uses the tools. So it produces a short history of the number pi, which it knows intrinsically in its training. And then what it does is it asks me to use the pi tool. So I'm just going to say the answer is 3.14. So, okay, here you go. It actually gives me 2. I'll just say this. And so it says, okay, I gave the results to 3.14, final answer, history as provided above. And I'll say no. But see, I would say I actually find this result disappointing. I wanted a full answer, right? Like give me the whole text plus the result. So let me just tell it that. Great. So I just said, give me a complete answer, and it does it. Like going through examples like that, where I completely took the code out of it, helped me understand MCP. Now, imagine for a second that you're writing some code and you have this code which uses an LLM like ChatGPT programmatically, and it's sending it questions, right? But now imagine you want to invoke other services. You want to get data out of a database. You want to run some calculations. How do you express to the LLM the tools it has available in a standardized way? And that's basically what MCP does for you. You could obviously hard code it and not hard code it, but you could build custom solutions that describe the tools to the model and then invoke those tools. But think about it, what MCP is doing is standardizing how we do that. So you can work across a whole bunch of different tools and quickly integrate tools and services. So for example, if you want to query data out of a database, there is a way to express that, right? So what we'll do now is I'm going to take this same example and I'm going to show you the code for an MCP client and server that does the same thing, but again, does it in the more formal MCP way. Now, not surprisingly, the code I'm about to show you, I had ChatGPT write. So this is really easy if you just want to play around with this yourself to just go have it write a quick MCP client and server. So let's flip over to that right now. All right, so here we have an MCP client and the server is behind us running on a virtual machine. We'll get there in a second. But this is not a lot of code. Let me just walk you through it real quick. And what this implements is a chat interface that leverages ChatGPT in the background. But let me show you, let's just look at the main function. So the first thing it does is it fetches tools. And if you look up here, fetch tools calls the server and it calls the tools method, right? And what this is going to do is return the functions that the server provides in a structured way. So let's jump over to the server and here we go. So this is the MCP server and here is the tools and this is all the functions that the server provides described in a very structured way. And it's the same thing we showed in the previous example, right? There's an add function that adds two numbers and it describes the properties it takes. And then there's a PyDigits function. Then you can see down here in the server is the actual implementation of those. It's not real rocket science, right? So back on the client side, the first thing we do is get the tools and we start in a history array. Think of this as the context. And basically we loop. And so we get some user input. And then what we do is just, drop the user input in and we start looping. And what we do is we call the GPT model right here. And what we specify is we specify the history of the conversation. And this is the set of tools it has available. And you can see, right, functions maps to basically the result we got from the fetch tools function. And what you're seeing here is basically GPT supports calling tools natively. And what I mean is it's built into their APIs and their function signatures. So this is already well supported. So basically you say, hey, here's the message history. Here's the capabilities you have. It sends this off to the model. And what you get is you get a response from the model, right? You get what it says back. And you're getting back a structured response from the model in this case. And you're going to see if the model is asking you to run a tool, to call a function, which is basically what we saw before when we did it directly in ChatGPT. Remember, ChatGPT would say, okay, now I want you to add these two numbers together. That's effectively what's happening here, where the message asks you to call a function. And if it does, we just extract out the function and we turn around and let's see, we execute the tool, which causes this client program to make a call over to this server, which we just saw, which would actually be executing the tool. And then you just loop through the result because sometimes you'll need to execute more than one tool and we'll do all the executions and we hand the result of the executions back to the model again to finalize its result. So you get the final reply and you show that to the user. That's it. So let's see what this looks like when it runs. So you can see here, I started up the server on the virtual machine and we'll just go back and we'll start up the client. And you can see right here, welcome to MCP chat. I don't have to tell it about the tools. It knows all that already. So let's try a similar example. Let's say add 2 and 3. Okay, so it says the sum of 2 and 3 is 5. But did that actually do anything? So let's just jump over to the server side. And what you can see here are the calls that were made. So you can see it made a call to get the tools, which returned the tool descriptions like we showed. And then here is the call to actually do the addition. Again, map this back to what we showed earlier when we were using ChatGPT directly. The model was given a set of tools to use. It reasoned about how to solve the problem using the tools. And then it told this client program, hey, I need you to invoke this tool on my behalf, which resulted in this service call. And then the results were given back to the model, which it used to produce the final result. I thought that's pretty cool. And again, the key with MCP is it just standardizes this whole process and the structure of these requests. But I think it's the overall flow of these requests in the life cycle that I had to get my head around. And again, doing it manually helped do that. So let's try this again. And let's go over here and just add a few spaces in. So again, let's try our problem where we add 3 numbers. Let's do 1, 2, and 4. Now we should see the tool invoke twice, right? 1, 2, and 4 is 7. And if you go over here, yep, same thing. You actually see the tool invoked twice, which is what you would expect to happen, which we saw in the ChatGPT example as well. Now let's go back and let's do the pi example again and see if it can handle that. We're going to make it a little more fun since we actually have the pi algorithm. So I ask it for a history of pi and calculate it to 10 digits. So we started that off and we should see a call over here to, there it is. So there's the pi tool, right? Let's come back. There we go. It gives a history of pi and then it calculates it to 10 digits and it gives us the result. So again, you can see here where the model was able to reason about how to solve a problem, break down the problem into different approaches, leverage tools, and then produce the result. Now, I think maybe the confusing thing is when I say the model did this, actually, right, we have this orchestration program, which is this client we have here. And that's the key thing is this orchestration program is using the model and orchestrating calls to the model. And then the program is orchestrating calls to the server on behalf of the model. The model isn't doing everything itself. There's this program handling the interactions along the way. So if you want to play with this a little further, what you can do is go in to your client code and you can just enable debug logging so you can watch all the HTTP requests and responses. Or of course, you could use another tool to watch that. So let me just show you real quick. You can see right here, logging.basic-config. Easy, I just did that, and you suddenly get a whole bunch of more output. So if we run this again, you can really see the request going back and forth where you can watch it invoke tools. So here's like the request to call the add tool and what it sends to it. But this will give you a little more information about what's going on behind the scenes. With that, we're going to wrap it up here. I wanted to make this quick and more of a conceptual look at what MCP is. Now, if you want to get into the exact syntax of the protocol and how to use it to implement different tools, obviously there's a whole bunch of other content about it. But like I said at the top, what I want to get across is more the conceptual. What is this and how does it work? And what does it mean when models use tools? And I think what I said is an MCP brings to the equation is it standardizes a lot of these interactions, which you could code them all up yourself, but extending it becomes very expensive to add more tools, more models, etc. Anyway, I hope this helped. And if you have any other questions, leave them down in the comments below and we'll see you next time.